You can't say that I didn't warn you. I told you it would come back, linear equations in the coordinate plane. So just to remind you, B is our y-intercept, M is our slope. So let's just start out plotting our y-intercept, which is just where the line crosses the y-axis. And we're going down 3, negative 3 over 1. There's an invisible 1 down there. We're going down 3 and over 1. And then we draw our line. It's not very straight. But let's just proceed anyway. And y is greater than and equal to. So I used a solid line. If it were just this, y is greater than negative 3x plus 4, then the line would be dotted. It would look like this. Not dotted, but kind of dashed. It would be dashes. But because it's also equal to, the line is going to be solid, like over here. Now, it's greater than and equal to. Where is it getting bigger? It's getting bigger on the x to the right, and it's getting bigger on the y above. So you're going to shade above it. I'm going to go through a couple example problems. And by the way, these are linear inequalities in two variables. When we see two variables, it's x and a y. And instead of using a number line, excuse me, because before we were doing just doing linear equalities, with one variable we just use a number line. Now we're using the coordinate plane because we have two dimensions here. We have an x and a y. So let's go to the next one. Okay, this one is just y is greater than negative 4. It's not y is greater than and equal to negative 4. So it's just simple. It's a dashed line just because it's just greater than. So we're going to do a dashed line, and we're going to go through negative 4. And y is greater. So now you ask yourself, where is y getting greater? It's getting greater above the line, not below the line. So we have a horizontal line through negative 4, and we're going to shade above it. And the solution is all these numbers, sorry, I should say all these coordinates above the line. Okay, now we have an equation in standard form. And I know I showed you how to find the x and the y intercepts. However, with inequalities, I recommend putting it in slope-intercept form because of the issue of the inequality sign flipping over when you divide a negative. So let's put it in slope-intercept form, which is y equals mx plus b. First thing I want to do, get this term out of here, and I'm going to do that by subtracting it. So I'm going to subtract 5x, I'm going to subtract 5x, and we can't combine negative 15 and negative 5x, so we have to write negative 3y is less than and equal to negative 5x minus 15. Now it almost looks like y equals mx plus b, but now I have to divide the negative 3 to both sides. And the negative 3 is going to go to both these terms, remember. It can't go into the negative 5, so we have y, and now we divided a negative, so the sign's going to flip, just like we talked about with the one variable. And we've got 5x over 3, let's see, plus 5, because it's a negative. These negatives canceled with these negatives canceled, I should say. And this negative 15 became a positive 5. Now we can plot it. Our y-intercept is a positive 5. And we're going to have a positive slope. So because of the limitations with this coordinate plane, because it's not bigger, ordinarily I would go up 5 and over 3. But if you go in two negative directions, then you're still going to get a positive slope also. Just because negative 5, m is equal to negative 5 over negative 3. Well, if you have two negatives, it becomes a positive. So negative 5 over negative 3 is the same as 5 over 3. Hopefully I didn't just confuse you. But I'm going to go in two negative directions, and I'm still going to have a positive slope. Remember, positive slopes go like that. Negative slopes go that way. So let's graph this. And I plotted at 5. I'm going to go in two negative directions. I'm still going to wind up with a positive slope. Down 5, over 3. And now I'm going to draw my line. I'm going to try to make it straighter this time. It's going to be a solid line because it's also equal to. It's not going to be dashed. And that's a horrible line. Sorry, I'm going to give this another try. I don't have a ruler with me, or I would, here, I'm going to use my phone. Try to lay it on here so I get a decent line. Okay, I guess that's a little bit better, but let's come back to the inequality. So y is greater than and equal to, so where's y getting bigger? And I'm going to show you how to test this, how to do the test also in one moment. But first I'm going to shade it so it gets bigger above. Now what we're doing, let's just pretend like we're second guessing ourselves and wondering if we shaded on the right side. Is it all the coordinates in the pink, or did I shade on the wrong side? Is it all the coordinates that aren't in the pink. We can do a test by just selecting, let's select a point. Let's select -2, 4, which is here. So we're going to pick a point in this shaded region, which we chose -2, 4. And now we're going to put it back into the original equation, and if the statement's true after we solve it, then we know we solved it correctly. So if I put, I'm going to use this original equation. I could use either. They're equivalent, this one and this one. We just manipulated it. We converted it. We changed it from standard form to slope-intercept form. 5, and I put -2 in for x. And my handwriting is looking really neat right now. -3, and I'm going to put the 4 in for y. I'm running out of room. Is less than. Yeah, sorry, it was getting too messy, so I rewrote it. Anyway, what I did was put in the x and the y in for x and y of our original equation, which was up here. And now I'm going to solve this. So 5 times -2 is -10. Minus 12 is less than -15. -10 minus 12 is -22. Is -22 less than -15? Yeah, of course it is. So we checked, we graphed it, we shaded it correctly. Okay, last one. What we're going to do is subtract the x from both sides, because we have it in the standard form, and we're not going to run into the problem that we ran into with this one, where we had to go in 2 negative directions in order to get the proper line. So I wanted to show you this. So -y, try that again, -y is greater than, I'm subtracting x from both sides, greater than -x plus 2. So now what I'm going to do is divide my -1 on both sides. So divide -1, and my sign's going to flip because I'm dividing a negative. So now we have the sign going this way. Y is less than, the one's going to both these terms, so it's positive x minus 2. And now I'm going to use a dashed line because it's just less than, dashed line, so -2. And our slope is 1 over 1. So we're going to go down 1 and over 1. Oh, sorry, up 1 over 1 is positive 1 over 1. And now we're going to draw our line. Come on, I can do this. And apparently I can't do it. I'm sorry, it's so hard to do on this tablet. This is supposed to be a straight line, okay? So just, and y is less than. Oh, what mistake did I make? Think about it. And don't yell it out because I can't hear you right now, because I'll be in the future by the time you watch this video. I was supposed to have used a dash line, so I'm fixing this. Dash line just because it's only less than. And then where does y get less than? It gets less than below. Y gets less than below the line, so I'm going to shade it below. And we just graphed this equation.